Right, welcome back to production line videos by the developer. That's me. This is going to be one of those videos where I talk about the technical side a bit because people like the last one. But I've got a few other things to say first. So this is build 1.25. I don't think I'll put the number up. So this is the build that went out yesterday. I didn't change the selections here because I know what I've got to do next. But I did add a rating thing. Which should be self-explanatory. How do you rate, the performance stability in front of the game at the moment? So, click on these however you feel that you should. Anyway, so I'm just going to show you something that went in and talk about it a little bit. I found a bug in it just after it went out. So this is my big factory that I'm playing about with, that I'm quite happy with. And it's quite late in the game. I'm just going to pause it actually. I have found that this is slightly different. The showing, this is a new screen market, and this has a bug in it. It doesn't show up properly, and it's really annoying until you've looked at your all of the cars that you've got on sale. I changed these scroll bars slightly as well. So anyway, having done that, if I now relaunch this thing. Oh, we've resumed. You'll see this. So this is kind of this is completely new. This is a breakdown of the market for cars in terms of the people who are coming to your showroom. So what it shows, it's always looking at the previous hour. So we had 150 people come to our car showroom in the last hour, and a certain number of them bought. So we had one sale, one sale, one sale, one. Oh, we had one of each. That's quite interesting. And it will show you how many customers were interested in each car. So, for example, 24 were interested in a sort of mid-range sedan. We made 2 of those. We sold 1. And you're only really going to get the full impact on the market if you offer one of everything. So people coming in wanting a luxury SUV, you just don't have one. So 7 customers did actually come in and they just went away unhappy. Now, obviously, if someone comes in 16 customers and only one of them is buying, so maybe they just don't like the look of it. Maybe that's just random. Maybe it's overpriced. We don't know. And if you didn't already know, you can look at a car here in the showroom. You can see what people think. So 20% of people looking at this car thought it was poor value for money. Most of the time, I might start changing this because most of the time it's just well, I'm not looking for a sedan, or I'm not looking for a mid-range car. So anyway, hopefully that's quite sort of helpful. Something that we're going to change here eventually when we do marketing is where it says customer visits to your showroom per hour is currently 150. That's because you're quite a small player and you're not doing any marketing. So what I'm hoping is that when you can research marketing and when you can launch marketing campaigns to promote your brand, that number will go up. So it could be that if you're really efficient and you're selling cars to everyone that walks in, it's we need more people to know about our cars, and that's where marketing is going to come in, and we're going to be doing that in a few weeks after I get back from a holiday. Oh my god, I'm going away for a week. Anyway, that's the stuff I wanted to talk about to do with the actual game, but some people are interested in the programming of it. So, what I'm going to talk about is multi-threading. This game is slightly multi-threaded, not massively, but more than most, because most games aren't multi-threaded at all. And a lot of stuff that people think in their favourite game engine is real multi-threading isn't. So, if I launch Task Manager over here and go to Performance and CPU, there is a way of swapping this. You can see utilization is really low. Even though I've got a game running, the utilization is really low, and that's because generally you're only using part of your CPU. This is a quad-core PC, and it's hyper-threaded, so you can see logical processors down there is 8. Effectively, I have 8 chips, and sometimes Not quite sure of the... Oh yeah, here it is. If you look over here, this is the key thing. You can see that there are 8 chips and they're doing different things. So if you want really good performance from a game, you want to use all 8 chips. If you really want to like push it to the max, if I want a factory 20 times the size of this, I'd have to do that. I've got quite a fast PC, so it doesn't strain it too much. So ultimately, the aim is to have the whole capacity of the PC working to do cool stuff. And to do that, you need to do multi-threading. And I'm going to show you what the multi-threading looks like if I quit this. So, the last video I did, I talked a little bit about the different tools that I used, and I mentioned the concurrency visualizer, which is excellent, and Microsoft have broken it. So this is a Microsoft tool called the concurrency visualizer, and the latest Windows update seems to have broken it. So it now just doesn't work, which is a pain because it's amazing. So the only tool I can find that does a similar thing is vtune, or be more specific, vtune amplifier XE. Why don't I just call it vtune 2 or something? Anyway, it's by Intel, and I've got a like evaluation copy. I'll probably buy it because I love stuff like this, but it's expensive. It's like 700 quid or something, about $900. And it's amazing. It does all kinds of cool stuff. So what I'm gonna, but I only use it for certain things. So what I'm gonna do is I'm gonna show you what I do. So if we go to new analysis, it can measure all kinds of crazy stuff. But the thing I'm gonna look at is concurrency, because I love concurrency. Concurrency is great. So what we do is press start. You have to do some stuff to your program to get it to work, which I'll talk about in a minute. So what I'm going to do is I'm going to load that same game. I'm going to play about with it a little bit, and then we'll look at the data. So here we are. We'll go to triple speed because that really puts a load on the chip. Generally speaking, production line is CPU bound, not GPU bound. We'll just pick anything because I don't want to be on that screen because that screen's really quick. Basically because I don't draw any of this stuff. So here's the game doing its stuff, blah blah blah. We'll draw loads of things, which will kind of overload it quite a bit, and then we'll quit. So then it needs to collect all the data about what just happened. If you run for a long time, this will take ages, but it shouldn't be too bad. Pay no attention to all the warnings. They're warnings about symbols that I don't have, but I'm not interested. I don't care what happened inside NTDLL because I don't have any control over it anyway, really. So then you get this screen, and I think some magic we can do that. Actually, I'll shrink it slightly just while we talk about this bit. You can do this thing here where you sort of say what you consider to be good performance. Now, I've said that basically 2 CPUs or more is okay. 7 or 8 is ideal. That's never. And all this does is it colors certain things. So if we go, I think it's this screen. You can tell why I like this stuff because it's just I like really complicated programs. So this is the whole run that we did here at the bottom. This is me launching the game. This is us loading. CPU went mental loading stuff, and then some like pre-processing stuff. And this stuff here is us actually running the game. So this is us running the game. That's the research screen. It's effectively single-threaded and very low CPU usage. Then we're back to the other stuff. A little bit of intensity there. I think that's when I opened all of those windows. Now you might think that's fairly useless, that screen, and it sort of is. However, here this is like the profiling-y bit of it to some extent up here, but I'm not particularly interested in this. I'm more interested in the stuff down here. So I'm going to switch to a view called Platform. There we go. See, it's much more much more helpful, isn't it? No. So what I'm going to do down here is I'm going to go to module production line.exe. Now what that should do is get rid of almost everything. All I care about is the threads that I've created and the code that I've written. Okay, I don't care about anything else. Interestingly, that one there, oh, see the call stack there, that's the sound middleware. If I click on other stuff here, it will show me a call stack for that. Which in that case goes into kernel base because it's the actual launching of the thread. Anyway, so forgetting about this one. In fact, I should remove that filter out. Yay! So this is what production line does. This is what most games do. So you have a thread, and then I launch another 7, and I launch another 7 on my PC because it detects. It asks the PC how many cores do you have, and it has 8. The maximum threads I want to run on my PC is 8. If I'm creating more threads than that, then what's the point? Because I can only run 7 at a time. And I have some code in there that does task scheduling that basically says this thread do that, that thread do the other thing, and so on. Obviously, it's stupidly more complicated than that. And this is generally how hard the CPU's working. Don't really like it to be spiky, but there you go. I don't think that measurement there is particularly accurate. There is another way of looking at this, which I'll show you at the end. So anyway, obviously this isn't particularly helpful, but we can zoom in. So if I zoom in a little bit, like that. Now you can see up here in the purple bits where it says G, that's something that I put in there. Each one of those is a frame. So that's a frame, that's a frame, that's a frame. So if we'll just randomly zoom in to just like 2 or 3 frames like that. Okay, so gameproc is basically my function that is a frame. So that's 1 frame, that's the next frame, that's the next frame, blah, blah. If I zoom in again to just 1 frame, so we'll zoom into about that. It's a bit of a graphics bug there. Now, this is where you're really going to need like a high-def version of this video to like read anything. So what I will do, I'll ignore all of this, but I'll kind of tell you what happens first. This is when we start the frame. This is stuff that we do. This is stuff that we do. This is basically the simulation. This is processing the simulation of the game up to about here. Then this TR, this is where we transform the tiles in software, believe it or not. This is where we pre-draw a load of the props, which are the individual like little bits on a tile. Other stuff happens here. We do some sorting of objects here into the hierarchy of isometric rendering, because we have to render stuff in the right order. Some other stuff happens here. Here we draw the GUI, and that there is the end. And what we do here is we just spin and wait until it's time to flip, which is like the end of the frame. So basically, I could end the frame here, and we've got all this headroom because it's a fast PC and I've written fast code. So that there is the kind of headroom. If a lot of stuff is going on, that will shorten enormously. Anyway, let me zoom in a bit more. So we'll just zoom in onto this stuff here. So that little there, VT draw zoom, that's drawing those little icons that are that represent the cars when you zoom out. That's sorting all the objects, as I said. What's that? Process vehicles, okay, and that's process route. So that's quite interesting. The processing route thing there has loads of other little sort of like droplets here processing other routes. So this is kind of I think that's verify routes, verify route. There we go. So every now and then, all of the routes between locations in the game have to be verified that they're the best routes. And we distribute those over frames, and we distribute those over threads. So at certain points here, various different threads are doing stuff. But the concurrency isn't particularly high. If we look here, it's higher because we've got like 4, maybe 5, 6 things happening at once. Pre-draw props, which is basically my transformation. And my deciding what props are where and where they should be on the screen, and preparing all the images ready to be rendered. There's a lot of stuff on the screen. And to make sure I don't make millions of draw calls and stuff like that, I have to do a lot of processing. And normally, all of this would happen in one thread, so that would actually stretch onto this, and we would be pushing the limits of the frame rate. But here, it's happening across 7 different threads. Now, let me get this right. I think if I change that to hotspots by thread concurrency. Yup. Okay. So now if we just go in again, we'll just go in to try and pick a fairly random one. Zoom into selection. We'll just pick that frame there. Now if I drag this up at the bottom, the CPU stuff, it just doesn't work at all. think that's a bug there. So this is thread concurrency at the bottom. You want that to be all green if you're doing the right stuff. So basically here, I've only got 2 threads doing anything. That's my main thread and the sound engine. And then here it bumps up, and there it massively bumps up, and that's because of the multi-threading. So I've saved a lot of time there, and little bits and pieces here. And then another bump up there where I do the next frame's pre-drawing. It really depends where we are. So if I reset the zoom back, let's just pick something else. Like here we go. Here's me rendering the what's it called? The research screen. For zooming on that, look, there's hardly any thread concurrency. And look where draw GUI is. It ends there. Like 90% of the CPU is being unused there because there's not a lot to draw. Reset zoom again and go for some sort of peak stuff going on here. There's a lot going on there, isn't there? And I have problems because occasionally, here we go, this is a perfect example. This is the sort of stuff I do all day for fun. Because I'm like that. Looky here. Process roots has suddenly taken about 10 times as long as it normally does. You can see here in the next frame, process roots is 159. I don't know what that is. Is it like nanoseconds or microseconds or something? So anyway, it doesn't matter. So that's like 159. So here, Jesus Christ, it's like 8 milliseconds. You've only got 16 milliseconds to do everything in a game. So there's a major like routing issue here. Now what's happened? Verify root. It's happened here, it's happened here. And then there's this big gap. Like what's happening there? This could be a bug. This could very much be a bug. And the thing is, I kind of get away with it a little bit. You'll notice that draw GUI still happens with loads of headroom. Because while that thread is busy doing whatever the hell I've asked it to do, I'm still doing all this other stuff. And that's because of concurrency and multi-threading. If I wasn't doing that, I'd have a big skip there. As it is, I'm not skipping because I've got that gap. But that worries me, and I need to look into that as a bug. One of the other things you can do with this, if I go to not summary, is it bottom up? No. This is the cooling stuff. Was it? No, I think it's top down. I prefer. Oh, and we don't want concurrency, then do we? We want hotspots by CPU. It's a stupidly complicated program. Okay, so if we do that, see, yeah, now it's lost it. Now it's lost it, hasn't it? Damn. There is a very, if I can get that to work, there is a very handy thing that you can do in that all of these measurements here are like for the whole run, and this is the way AQ time works, which is the profiler I tend to use. But what I can do is I can just pick a bit and I can go zoom in and filter by selection. So I can zoom in as I did then, but it also reloads all of this. There we go, and you can see everything's changed. So if there's only a certain bit of the game that I want to know where my CPU bound in that bit of the game, it's very handy for that. Like something's going on there. What's going on there? If we zoom in and filter by selection there, this will all recalculate. It loads an enormous amount of stuff. And I noticed this earlier. This is something to do with animated props. So redraw and set frame. I think this is to do with texture load. Anyway, you know, that's for me to debug. But it's quite interesting because if you don't have any way of looking at concurrency and you're doing you think you're doing a multi-threaded program, then you really have no idea what's happening, because you could have incredibly inefficient code running in a thread simultaneous with your main thread, and you'd never know about it because it doesn't affect the frame rate kind of like until it does, and then you think, what the hell's going on? Generally speaking, profilers are only looking at a kind of like linear series of events, and you have to remember, if you're coding in 2017, that you are basically coding on 8 chips at once, maybe 16 eventually. Who knows? And it's important to learn this stuff because it's really difficult. One of the things I'll point out, this is going on too long, I know, but I won't edit it because fuck it. One of the things that's really tricky and difficult and a bit of a nightmare. Let's zoom in on a particular selection. Hang on, reset zoom, and we'll do it again. Actually coding multi-threaded stuff is very, very tricky indeed. I'm going to put that back again. I don't care about all these other functions that are running at the time. So if I again look at a single frame, you might think, why are there all these gaps? For example, why can't we move that along there and do it there? Why can't we just crunch everything up? And the thing is, when you multi-thread something, you have no idea when it's going to happen. Okay, you can tell, like here, I've said, like, let's do all this stuff. And you can see they don't all line up, do they? They don't all like perfectly line up. There's a gap there, and there's a massive gap there. What's happening there? That thread probably couldn't run because there was no available core because it was doing something else. Maybe Skype. Who knows? Anyway, so you don't know when anything's going to run. So every now and then in my code, I have to say, okay, let's stop until all the threads have finished. Okay, so when I spin out all these threads to do this, we've got 1, 2, 3, 4, 5. Oh, that's the sound. 6, 7, 8 batches of doing pre-draw props. I don't know what side effects there might be unless I stop about there once they've all reported that they've finished, and then we can go on to the next thing, because I know what this code is doing, and it's only reading data and setting data within its own kind of like scope. But if I start doing other stuff here because we finished early, I might start writing to data that I'm reading here, and then you'll get a crash. And worst of all, you'll get a crash that only happens on certain PCs when there's certain background programs running on a Wednesday if it's raining. So like, it's a complete nightmare. So you can't just take all your code and scatter it. You have to know what it's doing. So you have to have like locks and waits and all these kind of critical sections of what I use. It's hellishly complicated, but you effectively get 8 times the performance in theory. So it's worth doing. And anyway, this is, I looked on YouTube, nobody talks about this. So if you're wondering, what does vtune look like? How does it help me look at multi-threading stuff? It looks like this. It's hellishly expensive. I only had it like a week, so I've got no idea how to use it. But I've already found it very interesting and very helpful. There we go. Nothing to do with production line. I will not be doing a video next week because, bizarrely, I'm going away on holiday, only for a week. So I will be back the week after that, and then I'll be talking about marketing. I hope this was vaguely interesting, even if you just like turn the sound down and go, well, that's what vtune does, I guess. Anyway, thank you for watching, and I'll see you in 2 weeks.